Hello, Hello, everyone, and welcome to the podcast. I'm newtmechanist, and today we're getting back into our game dev project. Did some work between the last time we coded and today, and hopefully we can wrap up the doors and start finishing out the level structure. There's still going to be some work to do getting it fully finalized, but we're just about there. Let's check in with the kitties before we get too much further. Let's see, we have Molly sitting on my lap. It usually doesn't last too long. Sky is over by the doorway. We have Ember across from the keyboard and Mason on the bed. Sherbet is watching TV over there. He is like right under it. When he turned and looked, that was because Sky climbed up on a cat carrier. Not clear where Sammy is right now. Not in any of the obvious spots. Yes, you're in the way of the camera, Molly. Yes, you are. Well, let's see. Put here and go over here. So, there's still some parts to determine where they're going to go, which bits of data. I don't really want to put this stuff here. But this is kind of where it needs to be if we don't use a special entity type. Hello, Sav. And is not the joke usually a 15 instead of an is? Or is this the new, less subtle trend? All right, so if we make doorways their own type of entity, just like the player or similar, then we can move things like which passage it connects to and similar into the entity. The collision for a doorway is ultimately just a generic collision event. It is just a collision message coming into the entity. But we need to get to that collision. Hey there, Key. Welcome. Let's see. If it gets a collision message, it would go through the gate. So we would need a pattern for informing. Do we actually care then? Thanks for swinging through, Sav. So if a collision door called out, we could go that way, but that means we need a passage. And I don't want to make special collisions like this for the entities. I want the passage to handle a majority of it. A collision message does carry the entity, which, if the entity is special, gives us the information we need. But I'd rather relay that to the entity itself in some way. How will it get it? How will it get it? So the flow that happens here, the code flow that happens, and how are you doing today, folks? Remember, this is kind of a social chat coding experience. We can all learn Godot and C# constructs together, and we can chat. So the way this currently works is that the physics server, the physics handler, will detect the collision. We get those collisions get aggregated, and then those messages are sent to the various entities. Those messages then bubble down the entity's behavior sets, which can result in additional messages. That the entity might react to. But it's kind of the nature of coding, Key, is learning to understand what's going on. Now, it doesn't mean I expect everybody watching to do that, but when you're learning to code, that's what happens, is you start to understand what's going on. That's why I'm not terribly worried about the whole programmers are going away thing. Now, I agree with one thing I heard, that the way that you go about programming may change, but I feel like there's a fundamental misunderstanding that's happening when people think of programmers. There is a industry kind of convention that junior programmers just write code. And I feel like that is a disservice to the process. It's, if senior devs are the ones that are thinking of system and structure and that kind of thing, then that means you have to have an apprenticeship kind of structure. And we don't do that. We almost have an adversarial teacher structure, where junior devs do work, and then the more experienced devs have to come in there and say, no, you broke this. This is how to do it right. That's not good. So if we look at it from a perspective of like, oh, AI will facilitate people thinking about big picture stuff and focusing less on raw coding, I don't disagree with the concept of focusing less on the minutia of what you're typing. So creating function headers, writing for loops and that kind of thing, creating the stubs of classes. A lot of that is mechanical work, just going through the motions that the language expects. But whether I do a for loop a particular way or not, whether I'm going to do an iterating loop, a for each kind of structure, whether I'm going to do event callouts, all of those choices have consequences. And if I abdicate my own responsibility in choosing them and instead hand that off to a language model, then we will rapidly reach the point where the skill set for that can start to erode. So now we have fewer people learning how to make those choices, how to do things like performance analysis, computational complexity, that kind of thing, and they just start to learn, well, this will work for my architecture. This box that I have received will work. Now, existing programmers might look at it and say, well, no, I want to make sure I understand it so I can evaluate it properly. But who's going to teach that? Who are they going to teach that to? Because if a company hires somebody whose experience with programming is entirely, hey, ChatGPT, make this app for me, and then iterates on that sort of pattern of, well, no, make it purple. No, make it save this information. There isn't the buildup of understanding in that. Doesn't need to be formal education, doesn't need to be some sort of formalized training, but we will need to preserve that level of technical knowledge, that level of capability. Same way with artists. Just because we have Photoshop now doesn't mean people stopped learning how to actually make the art, why choices are made, what things work well, what things don't work well. If the use of these language models in generative tools means that people forget how to do that or never learn how to do that, that becomes rapidly lost knowledge. And if you don't have that knowledge, then the language models will start to lose that knowledge. And we go in this loop of suddenly we have to regain that knowledge and build it back up. But the language models now have a preponderance of data that they are being trained on that is counter to that, that doesn't have that knowledge. So it's finding that balance, finding a way to use it as a tool without letting the baseline understanding fall away. And that's my fear with the way that it's being adopted right now, is there's a lot of marketing that says, well, you don't need that knowledge. I don't need to know how to summarize data. I don't need to know how to present this information. It's fine if you know, and then you can massage what you get. Like, hey, I have this information. I know these data points are the things I want in my presentation. Give me some slides that cover these data points, like this bit of information. That's fine. You're using a tool for that. Because a lot of times things like what the resume looks like is whatever the trend of the year is. The PowerPoint is whatever the trend of the year is. There was legitimately a period where Star Wipe was like advanced tech. It made your presentation look fancy. But that changes constantly. But if you have this big data set and you say, hey, language model, give me a summary of this information and write an email that covers it. Well, do I actually know what the summary, what the key points are? Or did I rely on the language model to tell me? Because if I can't identify those key points, how do I know it's right? And if I don't know that the key points are right, how do I know what the document that it's creating is actually saying? This is why we are getting court filings with random lies in them. We are getting code submissions that just don't make sense. We have open source projects that say, if we detect that you have sent us an AI code change or bug information, we're going to ban you. You can't play in here anymore because it's creating garbage. But if you have somebody who uses the tool and generates something of reliable quality, we're not saying that they're always going to create good stuff. You can still create bad stuff using a language model tool, a generative tool. But there is at least that level, that moment of responsibility and execution of your skills and your intelligence actually being the lead in the circumstance. And that's the thing that we're losing right now. He brings it up. It's what ChatGPT is doing to younger generations right now. Even adults, let alone children, we're really starting to see that loss of, again, an abdication of personal agency. It's, I can just ask whatever language model you're using. I can just ask that. It'll give me a result. It's okay. It's like looking at the Google top of the search results and assuming it's all true. We need to preserve that. And right now, that's not part of the consideration. And that's scary. That's pretty scary. Again, judges, doctors, lawyers using that and using it as an alternative to exercising their own agency, their own skill. and just submitting it as is negligent and actively damaging to the growing skills and intelligence of society. It's very disturbing. Again, though, the simplest way to view this is if everybody stops creating it themselves entirely and just uses these tools, what do the tools learn from now? And you eventually will get a garbage in, garbage out death spiral in a scenario where the skills decay too much. Okay. So back on topic here. Now, there's presumptions we can make where a particular passageway we can take the idea that doors are only interacted with by the player. Can I conceive of an environment where that is different? Yes. But if I know with certainty that if a collision happens, that we need to kick off the door logic, then that is a reasonable starting place. So if I have the concept of collision door, and it has, this is your passage, this is the door, but we need room, and only entity knows the room. We can extract the room. Entities intrinsically have a room ID now. The reason that we want room and door is so that we can inform the passage of that. So that the passage can translate whatever you tell it into an exit point. But then once the passage is done, it raises a series of events that say I am entering this room and I am exiting this door. Did I already make a message for exiting doors? Room exited, so we have rooms. We have passage exited. So which room and which door? When we exit a passage, when we exit a room, when we enter a room, we're saying this room is entered. So it's only when we exit the passage that we care at that point. And I don't want a behavior to be the one that gets that. Now, one possibility is that I just say this passage knows where to put you in a room, but I feel like that's a risk surface that I don't want to deal with. We could have entities register with a passage and say, I am the one that cares about this. Because then we don't have to worry about passage exited in the same way. We can just relay the message directly to the associated entity. So again, room and door matches an entity, and that entity is the exit point instead of the exit point being a room and door. An actual room and door. So if we look at passages, and where do I hide this stuff? I still need to home in on where I put some of these and further reorganize. Because I think I may have put it in services. It won't be an entity where we put passages. So we have messages here. I know I had this. Services, world state. Okay. Here we go. So right now, door passages have a source room to a target room. But if instead, when a passage is created, we don't have that listing, and instead we have an idea of a door as soon as it exists, calling out, like on an emitter, saying, that it will register to a passage. And passages watch for those messages, and say a door says, I am in room 2, door 3. So the passage goes in and looks at it and says, okay, whenever I get passage entered from room 2, door 3, the exit is going to be this entity. And that entity gives us access to the room ID. We don't need the door ID at that point for exiting. Which means that we still need a place to put the exit information. So then if we look at door collisions, we could have door collisions carry that information, but that doesn't really work for us. So if we have a door entity or a passage entity, so this is Stream of Consciousness, folks. If you don't get what I'm talking about and you're trying to suss that out, let me know, and I can probably go into more detail on that. Screens, game, behavior. We need the actual entities. So we have a player entity. We could have a passage entity. And passage entities are just gateways to the passage logic. So each gateway, each passage entity is going to be able to say what it is. It has a room that is assigned to it when it's created, and it has an identifier. That identifier is an integer. When we're defining a room, each door gets an integer identifier. So when that entity is interacted with, when it collides, we will have a behavior that is that the passage was contacted here. That will look at the source entity, because a passage collides with players. Player doesn't run into a door runs into a player. Same way an enemy doesn't run into a bullet, bullets run into enemies. And players don't run into anything. Players are run into by things. It's kind of a pair generation terminology. So a door collides. We can have it check the player, but that is currently a foregone conclusion. But we can have it say, is it a player entity that we have run into? And are we a door entity? So once we have that, we proceed in and say, what is the room ID of the door entity and what is its door ID? Having those two things, we can raise the event that passages would look for. And if that passage, passage ID, room ID, door ID, we'll have to make sure we cover all of those. If a passage connects to that, then it will take that information and identify the entity that represents the next room. That is tricky, though. We could have two collections here. We could have two. The passage determines which room and door you will exit. It will determine which door you are going into. Created all the entities. Are we doing that during the load? Let's check room. So we do the load of the room initially. When the level gets loaded, the room gets loaded. There we go. That's where we're attaching the initial events. So it's not until the room is activated for the first time. If we change it so that the entities are created up front, every entity for the entire level is created up front when the level is loaded, then we're good. But that means that there's a whole bunch of entities sitting out there. If we actually manage to finish up passages, Micah, then laying out rooms in levels to create maps, general maps, like they won't really have shapes and boundaries yet. They will just be regions that you teleport to. Then we will have that basics, and then the next thing after that is creating those walls and boundaries. And that gets into shenanigans that I am planning. But that will have to be at the start of a stream, because those are going to be some real shenanigans. Okay, so if we want to avoid generating entities before we arrive at the room, we need to have the room identified so that we can activate that room. We can trigger the enter room event. And then we can use the door entity that has registered that way. I still think we're in shape to do that, though. Okay, so we touch a doorway. We're going to use a collision event. We're going to use a particular message that would result from a behavior. So this is a passage entered behavior. It needs to be able to identify room and door. So we still need to have a way to connect the entities. Oh, we need to have a way to make the entities listen. Okay, so when we touch a doorway entity, we need to trigger passage entered. The passage entity will usually deactivate the current room and activate the next, or the other way around. It does matter, but currently it doesn't. Order of operations wise, it is different. Mason has left. Hello, Mason. Come here. What do I use for making design documents? Arbitrary comments and my brain, sadly. Sometimes my documents are scribbles in paint. Sometimes they're in the text. Should there be documents? Oh, yes. Oh, there should be. There should be. Yes, this is Godot 4.5 and C#. Once we hit the actual like room layout stuff, we're going to be doing some, what is it called? GLSL kind of stuff, the Godot flavor of the shader language. Yep. A vast majority of the footwork is happening in the C# code, but here, we will, I think everything is still working. I haven't changed anything substantially, so. The game screen, so this is the game. As far as Godot is concerned, for the most part, this is the game. I do have some other scenes. Some of them are vestigial at this point. Kicking off, if you aren't familiar with... So Godot is what I would call higher level. It's a scripting language for the most part. C# is a little more robust than that. And the further down that well you go, the nastier things get, you know. Again, like if you're using Unreal Engine, you're using C++, and that's near the bottom of the well. You can go deeper, but oof. But once you get rolling, it's actually really straightforward. There's some song and dance to get started. But that's it here. I have the main node of the game triggers is identified by this C# object. So then I go all the way up here to core. It extends a Godot node, so it is a Godot resource. I am doing everything I can to make as few things nodes as possible, because nodes are expensive. Doing arbitrary things in C#, not expensive. You can do this stuff on the Godot side. I like the structures that I can easily create here. And I also don't like the formatting of Godot script. But yeah, once you get started, and even this is almost vestigial at this point. We are almost past using this entirely. So if we run this on the Godot side, lots of crude stuff. We go to remote. This is currently the game. One second. We got to find some kitties. They keep moving. All right, Mason's back on the bed. Sammy is over on her roost. So I acknowledge you, Mason. They're up to something. So the code starts in core, and core is just a node. It doesn't have any space or physics or anything to it. It currently loads up a packed scene here. Many kitties, Micah. Many kitties. Just the start and end buttons. This just bails out of the app. This kicks off the next stage of it. So if we do start here, we're now in the game scene. And this is where a majority of it is. Again, we've got some packed scenes here. They don't need to be packed scenes anymore. Which means I will make them not packed scenes. We are on the inventory screen, so we have our grid here. This is generated in code. This one, I think, is still a packed scene. This one is generated in code. As many of them as I can, I am generating in code, so that their whole structure is fully controlled on the C# side, which makes it easier for me to do things like pull them apart when I need to. Physics server collision structure. This actually has no child nodes under it because we are interacting with Godot physics below the layer of the node tree. We're directly talking with the physics server in Godot. That can be faster. It's also more complicated. And you don't have any like visual engine for it. But faster is important in our process. Right now we have started in a room. This particular blob in the lower right is actually an entity spawner. It is the reason that 100 more blobs appeared. The blobs currently have their I inflict damage turned off, so the health bar at the top doesn't change. But we are very performance conscious in this project because of this. Let's let them all spawn here. There are currently, let's say, 7,250 mice. These little gray twirly things. There is object pooling going on. I need to revisit it and make it better. I have some ideas on how to make it a lot better. But the reason that I haven't revisited it is that we're not dealing with, I have 8 to 10 things that I'm going to recreate. We're dealing with, I have thousands of them that might appear. This is not expected to be normal gameplay, but it is technically possible for this to happen, and we want it to be possible. We're looking at a roguelike model, so we want the chance for the player to get so out of control that they effectively have already won the game. That moment for, the stars aligned and I got all of the best combos. Oh wow, we got a full hitch there. But even though it looks like the game is fully lagging, and it is, it's chewing CPU, the simulation, even though we're getting 10 like actual compute frames per second, the simulation runs at a static speed. So even if it takes a full second for the next physics frame to happen, that physics frame counts as like 1/60th of a second. So we don't get skipping or any sort of physics distortion. The world just kind of slows down. But yes, this mess is why we need lots and lots of optimization, and why the project has been taking lots of extra time. We have Currently, the visuals for these are actually sprite nodes, like Godot side sprite nodes. Oh, wow. Okay. Oh, okay. I took the spiral off. It's like, wait a minute, did that break down? But we now have only 11 things. We're back up to 2,200 frames per second. But even though we're running fast, because we're using delta and fixed tick rate, a frame is always exactly 1/60th of a second. Not in like clock time, but in simulation time. Learning is an overtime thing, Key. Overtime thing. Okay, that's... We do need to further cull this. So the indication here is that we have a collision between, for the most part, a collision between a bullet and an enemy that, as far as the physics tick was concerned, already happened. I can improve performance by ignoring that and not recording it, but this is one of those spaces where, can we tune it further? Because we don't process the collision when Godot says it happened, because Godot will do that as at the pace of the Godot physics tick. But I only want that processing to happen at a fixed rate. So if we get duplicates, we ignore them. But we have to deal with them. Song and dance. Okay. So we're back to doorways. Doorways are just places in a room. They're just entities that when the player touches them, it triggers a transition between rooms, or in the room, or to the next level, or whatever. So when the door entity collides with the player, then we need to call out to the level and say that this particular passage has been entered. Whatever the passages are, like transitions in the map. So if I touch a door, it calls out, and one of the passages hears it, is subscribed to a relative, to a corresponding message emitter. That passage takes control and begins the process of exiting the prior room, entering the next room, and then we need to put the player in the room at a spot relevant to the exit point that goes here. We don't want... So I want the entity placed in the room to be the source of truth for where the player exits. But the doorway in the room doesn't control which doorway and which room it goes to. That is the passageway, the kind of transition object. The door just exists in a room somewhere. And we don't land right on it because we want the player to not be colliding with the doorway. So each passage entity would have a position that is in some way an offset from where it is. This will be ultimately made easier if when we're in a model where you can't go back, like you can't backtrack, but we're building the system to allow us to backtrack. That is, if a player goes through a door, they could step back through that same door. Then if we don't allow backtracking in the actual game, it's just a matter of not having a corresponding passage on the other one. Oh, but that does... We could just have a passage entity that doesn't have collision be the exit point. That still gives us an offset vector from a passage entity to interact with. It's just that that entity doesn't necessarily have a corresponding exit. That's a layer of complexity that I hadn't thought of. That's part of the complexity that I hadn't considered, is how do we have a one-way door? We could make them independent, that an exit point is part of the passage pair. So there is a doorway that is the thing that you go through, that you touch in order to trigger a transition between spaces. But the exit doesn't need to be associated with such an entity. We just need that offset. Okay. So the passage entity is only a special thing because it needs to be something that collides with the player. It's kind of an enemy, but it's not an enemy type because bullets can't hit it. So it collides. And then we need to kick off a special type of collision event. So a collision message comes in, it goes down the behavior chain for the door. If it reaches the door collision, or collision door, then we're going to have an entity for that says this entity, the doorway entity, collided with currently the player. If the doorway has collided with the player, or any entity for this matter, it will trigger the passage logic. Passage logic goes off. Where is our... Hey there, show. We are trying to finish off passages and doorways today so that for the next stream we can move on to positioning the rooms, like placing them in space, so that we can have the enemies appear in the relevant space and start moving toward building out the actual, like, walkable surface and walls of the room. For those that aren't aware, the reason that we aren't using things like maps in Godot is we want to be able to do two things. One, performance. Collidable tile maps and surfaces in Godot do not play nice with the kind of performance we need to deal with. Even 1,000 bullets bouncing around and potentially hitting like a collidable tile map drains the performance fast. We are going to get around that with trickery and shenanigans, but that is the next step. All right, so we need our messages. So we have a passage entered, which gives us the door and the room that we came from. We don't care how it happened, but we get that we entered the room, the passage from this room and from this door. Passage is going to take that information and in some way translate it to another action. Which in our case is going to be exit the room, enter the next room, exit the passage. When we exit the passage, we just need to put the player in the room. We could have the idea of a door entity that does collide, but it doesn't have the kick off the door behavior logic. Just trying to avoid having too many instances of the same data. But if we have a door entity, I think we're still okay. Because the door entities act as collision points to enter a passage, as well as exit points, with a corresponding offset for if I exit through this door, put the player here. So I raise the event that I'm exiting through a particular door in a particular room. The door entity catches that information and moves the player to its exit point. And if a door doesn't have a door collision to kick off the whole passage entered sequence, then we don't have to worry about it. Okay. That means we do need a door entity. Single public extends entity. I'm sitting further back than I really want to right now, because I have to make sure I don't roll my chair wheels over Molly, who likes to sit under my feet next to the chair wheels. Which means sometimes I need to disturb her napping by kind of slightly rolling her away from the chair when I need to push it forward or back. Okay, we extend entity and public door entity, which is just nothing. This is our JSON constructor. Then we need a public override of duplicate or entity, which is the duplicate, is equal to base duplicate. This will be as a door entity. So in a lot of places in the data structure for this, the overall data structure for the program is, here, let me open in File Explorer, jump back to this, go into the data folder. This is the game's data. These are all of the things, visuals in here. Some of the things are full JSON, so like the definition of a level is fully spec'd out JSON as a single file. But we also have here. This is the current list of items, the tiles that appear in the player inventory. This is a CSV file that gets translated into individual JSON strings, which then get loaded into objects. But that is what I call the catalog. Those are the templates for things if I need them later. So we duplicate things so that you never mess with the source object. So if I get it from the catalog, I'm duplicating it from the source template. If I want to make a copy of an active entity, I can duplicate the active entity, and it will be the same thing with all the same values. I put this stub in here because inevitably I'm about to add properties to this, and the duplication process will set the values on the duplicate to the corresponding things. So entities already have a room ID. We need a public integer door ID. And a public vector2. Okay, let's get rid of this stuff for now. All right, the door entity, once it is active, and I'm going to need to make sure that we set it up properly so that entities become active only once created. Let me verify. Is our entity category structure active, active, active? Where is active? By default, active is true. That really shouldn't be. Add an entity. This is where we're putting it in entities to add. Hello, Sky. Hello. Cat some scratches here. We actually add the entity and then we activate the entity, which would go here. Set it active to true and we attach its events here. We should probably make this virtual so that we can extend it. Yes. Okay, so then in a door entity, I'm going to add some more here. I'm being orbited here. Let's see, where is everybody? Where is up in the tree? That's Sky on the right, on the canvas part of the table next to the little carpet. He's getting chin scratches. Mason has returned to the bed. Sammy is laying down in the play area. Sherbet just crossed over my headrest behind me a moment ago, but unclear where he is past that. Oh, he's laying by the door again. Okay. Public override. Protected. Okay, so attach and detach events for a door entity are that they are going to be looking for passage exited. And they only care about passage exited while they're active, which will happen when their room is entered. So again, passage entered, room exited, passage exited. So the room gets activated. That activates all of the corresponding entities, which will attach their events. So we are going to say services.resolve emits passage exited. Buttons. Equal to, we're going to do that and that. That. On passage exited, move you up here just for cleanliness. Okay. So, when a door entity receives the passage exited, because it's looking for that, it's listening for that while its room is active, while it is active, and it is only active when its room is active. Set that just in case. And again, it was brought up, but the only reason that this project continues to flow as it does is I'm able to keep most of a majority of what is happening in my head. Under normal circumstances, at the very least a folder of images and what amounts to like notebook pages torn out and thrown in a box should be maintained and periodically cleaned up, and that defines what the current goals are, what things should look like, how things should work. It is not a holy book. It is a mnemonic aid. Okay. But we need to know who. So let's add that to our messages. This will break some things. That's okay. Well, in theory, it will break some things. Then our passage entered. Same thing. Public entity get set. So And we'll do the same thing with room entered and room exited. Anti-itty. Okay. So, what this allows us to do is we know effectively what thing is entering or exiting a room. Under our current pattern, that is always the player, but this gives us access to that thing, and so that will allow us to eventually say, well, you don't deactivate the entities in a room, and those entities can follow you through the door. Or a bullet can pass into another room from the doorway and keep moving. We're not planning on doing that right now, but this gives me access to the thing that is coming through the passage. This will be useful. Edge entered, invoke. Okay. We're good there. We would need the player entity here. Same this way. Okay. We're going to take our first break for the day. I will be back in a couple minutes. And we're back. All right, so what we're doing here is we need to correct the generation of these messages. Get a passage entered from the passage, which means a passage entered message will have the entity. So it's going to be e.entity. So this is that sequence of events I was talking about. So the door entity, or more likely its behavior, is going to trigger a passage entered event. The corresponding passage is going to look for it and say, does this passage care about the pair that came in here? So room and door. If the passage does care about that, this particular one is watching for that, it is going to get the target room and door and is going to begin emitting the messages. So, for legibility, we are going to do this here. Just a moment. I have to scratch cat chin or he's going to mess with the mouse. Hello, Sammy. Yeah. Well, come here. Come on, then. Come on. Oh, you decided against it? Okay. Are you pouting, Sammy? Look at this. So Sky was getting chin scratches, and she walked over and started making motions that she wanted to climb up on my shoulder. But Sky was in the way, and she couldn't push past easily. So you can see her butt over there on the, it's kind of the top right of the camera. That is Sammy sitting there. That is as far away from me that she can get while still being on the table next to me. She is not speaking to me right now. I think Sky is going to crowd in with Ember. Yep, there we go. So you can just see Ember is still sitting behind him. That is the largest cat in front of the smallest cat. Int source room is equal to source.x. Every now and then the predictive text in this is great. Source room, target room. Okay. So for this one, right now, this is a short circuit. It's a bit of magic number, but when the level starts, it says you enter the first room. But that's not really what we're going to have happen. We are going to call out that you exit the first passage, or that you enter the first passage from somewhere. But for now, we're just putting them in the first room. This will come shortly. So we need a player state is equal to that. Entity player dot get player enters room 1. Double check, make sure I didn't blow anything up. Did not. This is technically room 1. Room 1 has a enemy that has spawning behavior on it. Every 3 seconds, once after 3 seconds, it creates a ring of 100 enemies. Well, 100 enemies all at once that spawn at random positions on a ring around the player. And then it stops doing anything. There will be spawners placed on rooms that aren't, like, invincible. So there'll be some that amount to enemies leap out from above the map kind of stuff. But there might also be enemies pile out of, like, the back of a van or something like that, and they keep clown carring until the van is destroyed. So the van is an enemy that does nothing other than spawn enemies out of it. Okay, so we have this sequence of events now. A door, and let's do a quick commit here. Okay. So the door entity has its door ID and a passage ID. Yeah, which passage it's associated with. Oh, but it doesn't care about the passage ID. Oh, it doesn't need a passage ID because all the passages are listening. Okay, good. Look at door ID is door ID. There we go. We're going to need... No, okay, no. We are going to need a way to get the position of the current room. But for the time being, this technically works. Hey, Jay. Things are going pretty well. We are continuing to march along through the door logic. Right now, the first room works. what we need to set up is subsequent rooms. Eventually, we also need to set up the logic that puts the player in the first room, as opposed to we just drop them on 0, 0 and hope for the best kind of thing. But we're defining the logic that we are implementing the logic that takes you from touching a door to the next room and out the corresponding door. So this is if e dot target room is equal to room ID and e dot target door to door ID. And we do that. Because I might not want them to appear at 0, 0 is the thing. That's actually going to be a relatively easy part to deal with. Right now, we have logic that says room entered, and it activates the first room. If we then also send a passage exited, and the passage that we exit is like 1, 1. So the assumption, there is a assumption in the system that says you start in room 1 at door 1. Door 1 just being the player's spawn point, essentially. Then this logic here would move the player to this spot. So if we look at base level manager here, so we have room entered, and then we would say I emits passage exited, emits passage exited is equal to that. Invoke that, and we send in this and a new passage message. Which has to have the player 1 and 1. So this is load the room, and this is move the player to the corresponding spot. Now this currently does nothing because there is nobody to listen to it. So we spawn here, that red dot is 0, 0. It's very, very tiny, but it's where the mouse is circling, just below the little bouncy robot there. All enemies evaporated. So eventually, the next thing is going to be, we would then define door 1 with an exit point of wherever in the room we want them to be. Okay. Hey there, Wilhelm. Welcome. Okay. So now we need... Should I have a checklist? Probably. I was mentioning it earlier today, at the start of the stream. Let's see. A Micah asked, like, what do I do to keep track of my game design documents, and what format do they take? And those should exist, and I should keep track of them and maintain them to some degree. Like, you don't want to be too rigid in those documents, but it's all in my head. I will write comments in some files to say, okay, I'm confident in what this file does. I will now fully document it. But this whole mess here on the right lives in my head. If I'm away from this project for too long, there are going to be problems. That said, the service model that we've implemented, the dependency injection pattern that we've implemented, is making it easier to handle this. There is one catalog, and then everything else lives in the scope of a single execution of the game. And everything is making use of this pattern here, except a couple of things. You can see the game object, the inventory UI, and there are a couple of other things like the renderers and such that haven't been converted over to objects that use Godot but aren't reliant on the core structures and scenes of Godot to exist. So instead of there being a packed scene object that I need to reference through some Godot resource that I inject into the system otherwise, I can just get a hold of it elsewhere. Begin scope, end scope. Yep. The advantage being is I have places that by looking at the code, I can more easily locate the flow that's happening. And this message structure is essentially the hub of the game. Okay, so we go to our door entity. We're looking for this. This is where it will set the offset position. And it only gets this if it's active, because this gets called when it becomes active, and this gets called when it ceases to be active. So we get that when it's relevant. Even if we didn't set this up and this was always active from the start, let's actually finish this marker here. Minus. It would still do the check to say, do these match? It would just be extraneous processing that would ideally never happen. Okay. So if a collision message comes into the door collision, let's hop along to that. So we have behaviors, collision behaviors. We are going to close a whole bunch of other stuff here for now. We have collision with a door. We don't need that, and we don't need that. What a collision with a door does... I think it's protected here. Process the message. Okay. Need an example of where I am doing that so I can verify that I do it right. Um, yeah. It's fun to explore different things. One of the projects that's not going to be online because it's a secret, um, will involve a lot of what is it called? Words and things. I should be able to see the name here. That will involve several WebSocket servers talking to several of the applications that run for the stream that will do things. Which has no overt like visual structure like we have here. But still. Okay, no, it's not one of those behaviors. It is movement, let's say move straight line, process message. Okay, so we get a reply that is the base and then we are adding to it. And you only touch it if you are going to set them to true. We can also create our own reply and merge it. But for the time being, we'll do it that way. Thanks for swinging through, Wilhelm. Collision door processes the message, game message, reply is equal to base.process message, entity message, return the reply. Then if we get away with this using message as collision message. And we'll just do if collision message. Okay, so if the message is a collision message, then we did act upon it. And now we are going to raise the entered event for this entity. So this would be I emits message entered, emits passage entered is equal to services resolve and then emits passage entered dot invoke. That needs a This thing is emitting this message, and this is a new passage entered message. We need another layer here. No. And this is the door that collided. Okay, so we have a collision message, and the source of that message is a door entity. Then we know that the target of that message should be the player, but that's not really the worry here. Collision message dot target. Then we need door entity dot room ID by door entity dot door ID. All right, so if a collision door event gets a collision message, and that message is sourced from a door entity, doesn't technically need that, but it really should. It really should. Well, at least in our current structure, it does need to. If it's sourced from it's a collision message sourced from a door entity, then we are going to have the target of that collision, in this case, always a player, and it will call out room ID, door ID from the door entity. Then a passage, on passage entered, is going to say, if I am watching for that room door combination, we are going to exit this room, which will deactivate it. We'll activate the next room, and then we're going to emit passage exited, which is going to go up to the door entity, which on passage exited, which it will be listening to because the room has been activated. It is going to position that entity based on the offset. We will need a way to, from room ID, get a door. I'm sorry, get the room position. It's not a string, I'm just... Okay. So that's going to be in the level manager where it puts things. But I feel like that also needs to be part of the room. I feel like that is probably part of the room. Factor 2, room, position. I will just say position. So It's where the upper left corner of the room's image, which will also be overlaid with the walkable space, that kind of thing. It is purely the visual construct of it that we're talking about here, and we're going to use that as an offset whenever we're placing things. So we're going to go to our create entities, and when we say position here, we're going to also say position. So by default, right now, the position of the room entities is relative to the position of the room. So if we run this again, we should still be okay. And it should do all of the same stuff. Yep. We should still get proper collisions. Yep. Okay. So now we have door entities. This is good. We have collision doors. And collision door just needs to exist. So when it's on that entity and that entity has the appropriate collision area, then we'll have that marked. And rooms with the position marker, we will need a vector 2 translation here. Just check vector 2 converter. Okay, good. JSON converter. Need to make sure I've got the syntax correct here. Type of. Okay, so that will let us actually define the position. Then we put the door entity in, which will have a door ID. And this will be the first one, so it's 1. Okay. Then we need to look at, let's get an interim here. A great deal of this stream is very mechanical work. There's a lot going on under the hood in this. A majority of the logic that we're writing has nothing to do with... Well, I'm sorry. The player won't be able to perceive a vast majority of the footwork that is happening here. They will just walk over, touch a door, and we transition to the next room in some fashion. Base level manager. We have level. We can get to rooms from that. We do need to be cautious about the way that we set up the rooms, because we don't want to run the risk of inserting a room and throwing off indices. Nope, they're key value pairs. Okay, good, good, good. Okay, so we just get it from rooms. Okay. So then in our base level manager, we can go into this and have, okay, it has a current room ID. Can have a public room. It's an interface, no implementation. And then we need public room, get room. That needs to have an integer to it. Then in our base level manager, we have int room ID. Room is equal to null, return room. If rooms current level dot rooms dot contains key room ID is equal to, actually we can just do a try get. Just so, oh, nope, nope. Okay. We try to get the specified room. Can also, no, I think we're good with that. Is equal to, can I do this? I didn't think so. Okay, so then we're going to look for, this gives us the actual room object. Oh, yes. Down here. We're going to have level manager. level manager, get room. Whatever the current room is. That. Okay. So then we're going to in there. Okay. So now we are going to need to go to our room definition. Don't need level entities anymore. And level map. We're going to leave those alone. Change what we need to for the time being. Okay, so this is room ID. This is position. Yeah, okay. So this is going to be 96. 196. That puts the room there. Then we're going to need a specific entity for this. A spawner. We need to make an entity for it. Okay, okay. And the entity's reason for existence. We're going to copy bullet here. The reason that this needs to exist is purely for visuals. Okay, its current category is 2. That's not what it's going to be. Need entity category. That is a player trigger. This is player can touch this. I'm sorry, this collides with the player, but it is not an enemy. So player triggers collide with. There is a here. Player triggers collide with the player. That is a 32. Uses the visual red dot, has no shadow, has a small collider. It does not have any health. those columns, we have a base behavior. Which will need to be a door behavior. Yeah, a door collision. Collision door. This is a collision door. Collision door, yes, yes. And that's it. It's just a collision door. Collision door doesn't have anything else to it. It does this stuff. So then we're going to take collision door here, and we hop over to this in our base behavior. It is collision door. So now we have we're going to explicitly call it door test. So now I have door test in existence. So we are going to do door test here. And it is going to be at 96, 96. It does actually have a thing. The door has a thing. The door has an exit offset, so we need to pull the same thing from here. So we have exit offset. That is going to be another okay, so the room is one full spatial element down and right. Then the door is one full down and right from that, and its exit is a further one. This does not have any behaviors in it. That should still be okay. So we're going to run this. I want to see if the door appears. There's our door. Nothing happens currently when we touch it. Let's run it in Godot and see if we're generating an actual error. We don't. Okay, that's good. Okay, back to the C# side. Okay, so for the door entity, we want to see if it gets wired up properly. It did not. Hey there, is it Gdon or Jidon or whichever? Either way, welcome. Yes, we have Sky on that camera. Let's do a quick cat check here. Oh, we can see 5 of them. The sixth one is under my feet at the moment. So the one that you saw up in the tree is Sky. He's in the upper left from your field of view. On the left side, we have Mason in the upper right, Sherbet in the lower right, and then that is Sammy on the left of the bed. And then in the lower right camera is Ember. Hey, Ember. Now she appears on the right. Yes, I called your name. Yes, come here. Come here. Come on. Yeah? Hello. So she went from the shelf, which is all the way on the far right wall, to a table that is right next to me, to my headrest. And now she is back on the table. Hello, sweetheart. So she double likes the right side of the table now because it is covered in canvas. And she is laying beneath the stream of a dehumidifier, so it's a nice cool mist. I do need to defur that canvas soon, though. Yeah. Uh-huh. Ember is very chatty. Of all of them, she recognizes her name. If you call out her name, she will usually come running. If for no other reason than she knows she gets attention when she does that. Okay. So by default, it should have collision door as a base behavior, which is over here, and collision door should just trigger that. So then if we look at I am making a Bullet Heaven Vampire Survivors style game. Roguelike Noida style weapon construction and likely room by room navigation that will be visually akin to things like brawler games or stuff like Metal Slug, potentially comparable to things like Binding of Isaac as far as like Zelda dungeon navigation. There's a lot going on. All right, where's our create entities? Okay, so the first entity should be a blob type that gets created. So we look at you. Yep, this is a blob type. Oh, I'm sorry. I get distracted in that. Thank you for telling me. That happens a lot. That happens a lot. Okay, so we build the entity, we put it at the relative position, and we get it ready to be added. Come back around, do it again. Entity has been created. It exists. It has a collision door behavior. Which is an 8-pixel circle. It is category 32. So we are going to offset its position. So it should be at 192, 192. Okay, it's 96, 96 because we aren't setting the room's position. when we instantiate it. That doesn't really exist in its current logic. But it... Oh. Doing that wrong? Not being ignored. All right, we'll double back on that. Okay, so then we're looking for the door entity. No, we're going to do collision door, and we're going to process message here. It is a time passed message. Okay, we have no collision happening with that entity. But why? And it is the door runs into the player. Should be type 32. Has no shadow. Let's do a layered if here. Doesn't really hurt us, but... Hey there, Lunar. Let's see. Did I add the TV in the layer main menu that only shows the old weather channel? Actually located a place recently. I was actually in a place recently where they did have like the local weather broadcast on loop. It's kind of felt kind of uncommon. Okay, we are going to say if it's a collision message. We know it's getting created. Okay, it is a collision message. It is an entity. Its collision mask is 1. That's the player. No. Visual bullet, red dot. Why is it 1? How is it 1? It's a room ID, but it doesn't have door ID. It is not the right type. Door entity type. Oh. You need to be specific about its type. Like, it's okay that this one is a generic entity, but this one needs to be a door entity for it to work. Nope, still didn't do it. It's category. No. It is a 32. It collides with 1. It does collide with the player. That is correct. It's sitting in the right spot. Doesn't move. But it doesn't have all of its data. That should have happened at least once. Should have happened at least once. No, it wouldn't, would it? Because we're just defining... These are room entities. This doesn't matter. Let's look at door test in here. It's not type entity. It's type door entity. Found it. Womp womp. Yep, we duplicate it. It is activated. We attach events to it. But there is no passage that reacts to it. So we need to get the passage in there because the passage is going to be the one that says, put them there. It's if things work, we will appear down and right from the door. So now in the room, we need to make sure we get the passages in there. Kate. We have a list of room entities. We have our world map. That's part of level. It's part of level. Passages. We have a list of passage objects. Passages need to be activated. We can't just have them do their thing immediately. So we can't do this. So, oh, I'm sorry. We can do this, but there needs to be a explicit active state on them. We can follow the same pattern and just do a load on passage. think I missed a spot on this. Yeah, interesting. Oh, okay. No, it's that the object needs to implement that. Yeah, we're just creating that for now. Okay, so we need a public void load, and then door passages. Public void load. So that properly implements the event now, and instead of this, we do this. Once the passage is loaded, we're ready to go. So then in level, which I did not open or I closed again, but in level, we load the level. For each room, we load it. And then let's see. For each passage in passages, passage load. Okay. So then in the level manager, when we get a level start, we're going to kick this off here, passage exited. So if we look at a door passage, we have passage entered. Okay, no, it's the door entity. Here. Okay, if we look at our stack, we're activating the entity. Okay, so it has entered the world. We have attached events to it. And this is after a... This is the physics tick after the room was entered. That this entity has popped into existence. This is actually tricky. Yeah. Okay. We need to wait a full tick before, like, once the room is created, we then need to enter the level. So there's stages to this. So when we enter a room, we add the entities. But the problem is that we are not, the entities don't exist until they're ready. I'm sorry, they don't exist yet. I cannot react to emits passage until the doors exist. The doors don't already exist until we did a full level start. So there is essentially a separate step here, where what we are doing is we do room entered and then we do passage exited. I'm sorry, the player is ready to exist or exist somewhere in the world. We need room entered and passage exited to be able to happen right away. We don't want to wait for the world to trigger. So level start happens in the core of the game here. With the level and then I think it's actually in the main menu. Okay. All right, we are raising our start game event, which the game should react to as like an on start game. Do. There we go. The game over. This is on. Oh, okay. This is in core. On start game. Okay. So we pull the menu down. We trigger load game. So that starts the scope. We attach the game. Go into the game. Base. It's going to go into ready. Set everything up. And we trigger level start here. There's kind of a sequence that we want to go through here, like a series of steps that we want to enter. So right here we have load player. Technically, we need to make sure that happens in the right sequence, but we have set the level. That gets the level object into position in our level manager. Level start is when we should trigger the that is our room entered and then our passage exited. Room entered will activate all of the entities. But if they aren't created by that point, there's essentially a tick that has to happen. We need to that there's a gap here. So if we do level manager, this happens in a series of steps. So this is where we could load the player. So we enter the room. Any progress with the computer tasks, or have you not had the opportunity to get it looked at? Let's see. Unfortunate. Base level manager could react to a series of steps. So once we do level start, we know that we have to be able to wait a series of ticks, but we don't want to assume we know how entities are loaded. We have hit an order of operations snag. So again, entities don't appear until the top of a cycle. Level start happens early, but even if it happened early, that does not instantiate the entities yet. Now, we could have a method that is to force the entity manager to take action on them, like right away. So if we look at base entity manager, normally when you call add entity, internal, right here, it adds it to a queue and says, okay, we're going to have boundaries on it. This doesn't actually need to happen. Max entities doesn't have to be a thing. That was there to deal with limitations when we were trying to do shader-based collision. But in any event, let's see. Hello, pomegranate. Took me a moment to read the upside down. Because, let's see here. We know that an entity has been added. But we don't know if we're done yet. Thanks for swinging through, show. Hope you have a good day. So we know that one gets added, but we don't know that we're done with them yet. We can queue them, but like I said, there's a window in the entity manager. But no, we don't want to know how the entity manager works. That's our problem. And we don't know how many entities will result from loading them. Oof. Oof. Because the whole point of the delayed action to adding entities is to ensure that it doesn't happen in the middle of it. But actually, does that even matter anymore? I don't know that it does. During world start, we remove anything that's queued for removal. That's okay. Then we add anything that we're going to add. But that's just to iterate over that. Because we switched to this handling, yeah. I think we can remove the desync of adding entities. They can be added right away. That means they can get a collision immediately because the physics tick will happen at the end of it. But we don't need this anymore. We do not need this anymore. The removal is still necessary. Because we want the entity to continue to exist into the physics step. So if in the series of events an entity comes into existence and something happens to it that would remove it at that moment, it still has an opportunity to act on every interaction that was available to it. So you can't have an entity appear and immediately get deleted. It gets a full series of steps. But adding them, we might be able to just do this immediately. All right. Intermediate save. Okay. So what we're going to do instead of this set entity events does nothing. Because we don't care about it? Do we? Nothing happens there. Okay. So let's rip some of this out because we aren't doing anything with it. There's a lot of vestigial stuff still hanging around. So we have add entity internal. What we are going to do is when we add entity, we are going to short circuit this. None of this does anything. Yeah, we're changing two things at once. I don't care. So we do add entity here. We are going to just do that. And we are going to do add entity internal for the supplied entity. This does mean that anything that's added right away in the middle of a step has the immediate opportunity to act on subsequent steps. This could break some stuff, but that's okay. Okay, so what we've done here is that we no longer wait a whole frame for enemies to be loaded or entities to be loaded. It happens right away. And it totally broke stuff. Okay, we have no enemies loaded. We have no entities loaded. A subtle. Oh, sorry. Ha. Okay. So one of the subtle things, there's no outline around the character. I actually don't mind this. I kind of I kind of find unoutlined stuff charming. But okay, this broke. Ah, okay. Okay, we need some more. Right here. We need to set its ID during this process. Again, we've removed the delay here. Still not working. Let's check the Godot side since it will record errors that we don't always see on the C# side. None of them are visible though. Okay, okay. That. First one that should get added is the player. Yep. I'll activate. The player is now activated. Entity is a what? Okay, this is the blob. So we are iterating over that. Die. He's yelling at me. Scratch my ears. Internal. Oh. For time. Because it doesn't have an ID yet. Okay. Okay. Again, we are making some fundamental changes to the way entities are loaded. Okay, so the player's outline isn't being triggered properly, and the player did not start in the appropriate location. Okay, so let's go back into our level manager here. So I have player. Player's position should still be 0, 0. Yep. I have not created the passages yet. Okay. So there's something that's still wrong with the way that the player is loading up. So the player is loading immediately. Again, we're probably going to move the load player into the level start sequence. That was happening because the player was being loaded before the visual structure got into place, which meant that its outline shader wasn't happening. Okay, fix that. Now we need passages in the level. So now we've got our rooms list. So we have room 1, which contains all of this, which includes door 1. Okay. We have passages, which is a list of passage objects. So this will be a type. It's a door passage type, and a door passage has dictionary of vector 2 pairs, vector 2I pairs. We have some other places where we did a dictionary. But I don't have a clean way of creating that. I think I'm going to have to make a converter for it. A vector 2I pair dictionary converter. All right. Let's check a couple of things here. Yay. And this one. Okay, we're going to take a quick break. I will be right back. Okay. So the next thing we need to create is something that will create the pairings that we need. Okay, we've already had to do this once before, so it's not a big leap. JSON helpers. The vector2 converter is what we use here. How do I want to do this, though? Even tuples are going to be kind of a pain. What could I do to make this cleaner? Well, thank you, Cliftonia. I'm glad you enjoy it. Oh, tuple. Float, 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 float. Test. Test dot. Item 1, item 2, item 3, item 4. But it'd have to be a key value pair. There's a way to do that. Oh. How do I want to represent this? Even a list of vector 2s. That's not out of the question, actually. What does my vector 2 converter do? It outputs a list of vector 2s. No, this is just a vector 2. Okay. Sky. Hey. Oh. Node cache, that's not what I'm looking for. Vector 2, we have a converter. So we need key value pairs. They need to be... This is so ugly. Because we're going to get a value, and I don't want to be too fiddly with that value. If I just had a list of vector 2s, then I can make a converter for that in a straightforward enough fashion. Because if it's a name list converter here, we have start array, end array. Okay, if we split on... I am right now. The puzzle is getting this out of JSON. So I have each piece of this. So like for this one, the string value, I split on the comma and I parse each of those pieces as floats. So the space gets ignored in this scenario. In the next pattern, we need to have a delimiter for the pairs so I can have a list of them. So we would have float, 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 essentially. Now I can still have just comma delimited. And we might just be the way to do it. It's ugly, though. Don't know. Well, I mean, since it's going to be in quotes, I don't have to worry about that. So we're essentially piecing apart values here. So we get the value. So we get the line item. We now have a string. In this case, like we've got a catalogable name, but I can parse the name into the resultant line item in the array into a thing. And I only need it to be a series of values. Again, 4 pieces. I think we'll just go with that. Is a vector2 to a vector2. Could just have 2 lists of room, door. Well, even 2 lists of vectors. We might as well do a dictionary. So this is a... Could just be a tuple. And then I don't have... no. What do I call this monstrosity? Because it's a vector2 keyed dictionary of vector2s. Okay, vector2 dictionary. Converter. Converter. Oh my god. All right, vector2 converter. Yeah, the vector2 converter is there because there isn't a clean way of getting the vector2 by default out of system.text.json. There might be some roundabout fashion of jamming it in there, but the values don't seem to line up. Oof. This guy crawled on my lap, and then Molly was like, hey, I want to do that. And then the two are sitting right, like, are piled together, and Molly isn't thrilled and Sky isn't thrilled. So then I get kicked off by Sky and trampled by Molly. Do I want to do that? I can't think of a more efficient way to get the values. We still want the vector 2. It's vector 2i to vector 2i, actually. Ew. It's one of the longer class names in this thing, but, you know. Converter of a dictionary of vector 2i to vector. You're not being helpful. And that's using Godot. Actions, implement the class. Oh, passages. Okay, 2i to 2i. Again, room door to room door. Don't care about write. Can explode if I try to write for now. Converter, we're going to read. We're still going to do this same thing here to here. But not that. Dictionary of I result new that. Ooh, boy. How's all this for now? Snap this whole mess. Hair. It's a quad. We're calling it a quad. Vector 2 converter. Arts is to split that on commas. And if arts.length is 4, 2i source Why? That was... What was that? int.parse. Legitimately confounded by that autocomplete. Add source to target. If not ideal, but it'll do. Gross. It only exists in JSON little compiler notation, so I don't care. Well, I do care, but I choose to think that I don't, or declare that I don't. Oh. JSON converter. Yes, I'm taking some JSON and converting it into a dictionary that is a vector 2i to vector 2i. So integer two-part integer vectors. Two-dimensional integer vectors. Should be type of vector 2i monstrosity. Okay. Okay. Not okay, but sure, fine, whatever. It's a door passage and it has pairs. So we're creating code that tells system.text.json how to interpret the value that we're supplying it with and convert that into a dictionary that has a vector 2i key and a vector 2i value. The same way we have a converter to tell it this is a vector 2. So in the definition of a level entity, we say this is a vector 2 using a vector 2 converter. Pairs is an array, and we are going to parse that by doing this. So this is going to be a 1 1 to 1 1 actually. 1 1 comma 1 comma 1 comma 1. We don't actually care about this one. Or this is how this one works. We can actually put 0 here. You never enter this passage. I could actually make it so that you enter this passage. All right, we're going to leave it this way for now. Oh, boy. Don't worry about asking questions. Just ask whatever questions you want, Cliftonian. Things get weird. At least code-wise. iPassage. iPassage is a catalogable. It is a catalogable because it implements... No, it's an interface, and in order to support that interface, it needs to be implemented here, which it does. But this is the first time we've tried to do this part. Give me that error again. Oh. Because it's treating it as an interface. We don't want it to be an interface. This is going to be in... We're adding that, but when we parse it, we're getting I... We're going to skip that one. Which means we need to go up to this. Catalogable types info. We have a... Okay. Where type is a type that is assignable to a type of catalogable, and that type is not iCatalog. And okay, let me do a quick research here. Is interface. Okay. And not type.is interface. Technically, this overlaps here. We are explicitly saying don't do catalogables. This should have caught it. It should have caught it. Well, let's see. Nope. Middle of an exception. I mean, I could just have it be a layered type, but that's asking for trouble. Like, I could have them implement both passage and catalogable. But I can't get the corresponding values here. So this is going to iterate over all of the things we've found. All of these things. Hey there, Laura. But it shouldn't be a type of iPassage is the thing. Store passage is an iPassage, but an iPassage is a catalogable. But that just might be the problem. Said it's a type of door passage that matches the name. And this will explode here. Ah, good old Monty Python. Door test. We are looking for level test is what we're seeking here. If okay, the key is level test. Our immediate window, that. It's a level type. It's entity, position, behaviors, spawner behavior. Passages. It is a door passage type. Why can it not find that? So it should explode right about here. Yep. All right, we're just going to do a test here. I don't fully like this, but what are we going to do? Hey, Nomable and friends, welcome everybody. The cat currently on camera is Ember. She's the tiniest one. But welcome. We are... okay, this didn't help us. Still explodes. Okay. That back. Hey there, Nomable. Still explodes. Interface or abstract. There, it is neither of those things. It is one of these. So that didn't change it, and this doesn't help us. We're just gonna we're throwing stuff against the wall here. Okay, didn't do a thing there. We're ruling stuff out. That's good. There's some values of good. Boy, I need to go through and clean that up. So it doesn't like when we're parsing this one, it doesn't like getting to here. Oh. Oh no. No, that's right. That's right. Passages is a list of passage objects. It's a defined type, which we should be locating. Let's do a quick sanity check in the middle of this. Or Our type name is door passage. This is one of the little bits of sorcery that we do in the code. So in order to cleanly deserialize without having to go into every child class and define every child, into every class and define and interface and define everything that can be derived from it with a keyword and do that repeatedly throughout the whole tree of objects, we do this, which extracts a pattern of that from the runtime. It is a door passage, yes. And it is a type of door passage. And we are already deserializing into catalogables where necessary. So it is here where we're deserializing it to a catalogable, and it is resulting in it saying that it cannot deserialize to an interface or abstract type. But why would it do that? Because I'm calling it this. This is what it is. I'm missing something. We have the type declaration. We have the pairs declaration. Passages is a list, which is part of the level definition. A list of iPassage types. These are iPassage types. Just like it can deserialize to catalogables. Oh, no. Okay, it implements the interface, but that's not what we're deserializing to. It's trying to literally deserialize to that. So to get around this, we need to add just a passage. And passage is a public class that implements iPassage. Which is here, which is, has load and has this value in it. So we go into door passage. We still have catalog name, but that's going to inherit down. So this is going to be a passage. And in passage, this is where we implement that stuff. But we also need to have a public void load and duplicate. Should room walls be recursive? The Lost Woods stuff would be handled by a more complex passage. So you would define like a sequence in the code or just an algorithm in the code to say, I have to enter this passage in this way. in order for me to proceed to the next door over and over and over. And you could be using the same room repeatedly for that. It's the passage kind of lives separate of the rooms and acts as a transition when you cross along. So the Lost Woods one could deactivate and reactivate the same room repeatedly and load you into it at arbitrary points in that room. It could do whatever we want it to. Okay, by default, it's virtual. Load doesn't do anything for this one by default. And duplicate doesn't do anything by default here. But actually, no, duplicate does something by default, and we do the same thing that we do in all of the other ones, which is find the duplicate function and just jump to it so I don't have to hunt for it, is this. Once again, more sorcery. Not really. This is pretty tame for sorcery, but passage. If we had any default values, we would load them here. So what this is calling out is, I think this passage loads. So what happens is we are saying whatever type of passage this is, whatever child type of passage that this is, we are going to create one of those right now. So whatever type we are. And then it will kind of ripple down through the parent classes, filling in their values. Right now, Lunar, the look of the place is going to be a fixed image. We may eventually get to some procedural generation, but it will be, I have exactly this. So there isn't any really like templating. It's more just what I chain together, like in the files. Okay, and then a door of passage extends passage and has its stuff. Then we're going to override that. And that is going to be base.duplicate as a door passage. And we do our thing there, and this is an override of load. Quick build. Now, longer term, we may circle back around and have other methods of map generation as opposed to like handcrafted rooms. You know, circle back around to like tile generation, that kind of thing. Do some of the collision logic on the fly. And then we could have things like it uses this tile set kind of stuff. But we'll look back at that later. I thought I had it. Oh, wait, did we change it yet? Level. Passage. I win. Okay, okay. So now, do we ever call duplicate on the level? We should. Okay, so right now we have this. We have passages, the door passage, which has nothing in its pairs. Okay. So if we look at our little horrifically named converter, we're to level again, and we go up to passages. No, it's in passage, door passage. Should be in entity. Should be able to find a pattern for that. Converter type of catalogable. Is catalogable. Never reads that. Never does that. This never happens. Why does it not happen? This should be triggering. We should be loading this in. It's called pairs. It has a list, but it's never deserializing that. It is within door passage that exists. Passage exists, it just has nothing in its pairs. And we got door passage here. That worked. And then we should be getting child types of door passage off of it. I'm sorry, of passage off of this. So this first pass of types is everything that directly inherits from iCatalogable. So we have one layer down, but we should be able to go any number here. Yeah. So the first pass is, can it be a catalogable? So that collects pretty much everything. Then we go through all of those things that can be assigned to a catalogable, and we get all of their child types. And we lump those together and run them through the list and insert them in here. So why does it not like that portion? So it can be a passage. It is a door passage. It has a JSON constructor. Just make sure. That should be the case, but extends passage as its JSON constructor. I'll duplicate. We get the base out of that. Okay, this part isn't happening. But if we look at passage, didn't this happen? We're never getting duplicate out of these, which means they're not getting to the catalog properly. So let's go to game here. And we're going to, in our ready, where we're loading everything up, right here. So the get that happens in this. It is a level. It has passages. There is a door passage there, but its pairs come out as 0. So our converter for getting a dictionary isn't right. So we're never triggering this. This isn't getting loaded. Dictionary of vector 2i to vector 2i. That should be the marker. And in level, in passage, which is a door passage, of a JSON converter of type vector 2i to vector 2i dictionary converter, which will return that. Guess what's missing? We'll give you guys like a few seconds here. There is one silly thing missing here that is critical. It's not public and it's not a property. Welcome to debugging. Okay, and we're going to get our level object here. So we're getting it from the catalog. So we have one passage, we have a door passage, it contains pairs, it has a 1-1 to 1-1. Now we're still not being put in the correct position here. We should show up here. But we can trace that series of events out. We're getting closer. Getting closer. So now, in the sequence of the load up in the level manager, our world state, level manager, base level manager. We are in particular looking for this sequence here. So the level loads. We go to level and we go to load. Each passage loads. And when a passage loads, by default it doesn't do anything, but a door passage is connecting to those, because passage by itself doesn't do anything. We can set that up as universal, but I'm going to leave it alone for now. So we want to see if we get here. Actually, I think I know. All right. So in a level manager, we have level start. We're going to emit room entered and passage exited. Passage exited should be something that a door entity should be looking for. So this is when it is activated. So we're going to try to catch that on passage exit. That is the second part of the startup. Okay. Target room is 1. Its room ID is 1. Target door is 1. Its door ID is 0. And it has a door. It doesn't have the door ID set. A door test entity. Oh. Where do we put that? Where is that? It's part of the door entity, which means it's part of the entity's definition. Don't want to have to fully spell that out. Okay. We could have a separate list, which is a doors list. Which would be defined entities, but I'm not really fond of that. Because entities can be relatively complicated. You know, room entities. Entities is a list of entities which have an entity, a position, and behaviors. Okay, that was already not working. We were already doing that wrong. So room has a list of room entities, which is this thing here. Room entities have an entity that is defined, and we're pulling it from the catalog. They have a position and they have behaviors. That does not give us what we need here. I want to be able to define different doors, but then I would need to be able to give the door an ID here. It can't be the entity's ID. So there needs to be a mechanism for setting them up. But only door entities have IDs. So we could have an explicit list of doors in a room. That is still uglier than I'd like. Because if we look at any of the entities, we have to fill in a lot of stuff here, but that's not end of the world. Because it just needs to be this kind of thing. And we're never going to give it a name. Okay. Let's roll with that. Public list door entity. Door entities get set is equal to new list door entity. So then in the duplicate door entity in door entities, we are going to say duplicate dot door entities add Okay, that duplicates the door entities. Now, door entities are an explicit thing defined in the JSON. It does not have a converter for them, so you must fully define them as entities. So room 1 now, instead of... So we have the enemy blob, and then we have a door test. We are going to have now doors. Which is a list of entity objects. Which have a type. Well, explicitly they are door entities because the list says so. But that's fine. So we're going to have behaviors on it. Should be base behaviors, I think. Category 32. We have base behaviors. which is collision door. Visual key, which is bullet red dot. And let's see, shadow width of 0. And collider key. Anything else we need in here? I think we're good. So then we load the doors in the same way that we're loading the door entities. This... part of that WebSocket project that I'm going to be doing is to try to get something that is not the Twitch tokens, the standard Twitch currency, that is applicable across YouTube and Twitch once again. But that will be its own little song and dance. Okay, so when we load entities, we create entities. Thought so. For each door entity indoors. Entity manager dot. We also want in entity, we do have position as an element, don't we? It's being ignored by JSON, but I'm going to unignore it. Because we can totally set that. That is a vector2 converter that is needed for that if it's present. JSON converter of type of vector2 converter. So its position can then be set to 96 U. So that'll set its position. And because it's a door entity, we're fully specifying everything else. This is going to have a door ID of 1. And an exit offset. Which which is another vector 2 converter of 9696. Did I break something? Don't duplicate as a door entity. Unlocking emotes, always good. Okay, the level did not load in this scenario. Which means there is something wrong with this structure, which includes this comma right here. I do enjoy the piano. We have gone through a lot of different types of music, Cliftonia, and the, you know, soft to sad piano and strings is kind of where we are. One and one and one and one. Ah, not yet. Player is still here at 0, 0. They should have been here. Player entity, they're at 0, 0. The exit offset is not loading properly, which is because we are not doing that in duplicate offset. We're also going to check in room and verify we're not missing any new values in our duplication. Once more. Zero, zero, our exit offset, and our current room position isn't specified yet. We get our current room. Its position is still 0, 0, which is fine. Haha. It's not perfect because we are appearing. This is position plus. So our position offset by our own value. So a distance off of us offset by the room's position. So relative to. Ta-da! And now doing this should have thrown me here. Okay, so then we are going to commit that code. Ah, small victories. Okay, so then we're going to check for passage entered, and we're also going to look at our collision door here. Arrive here, touch this. Didn't get a collision. Let's... Okay, collision is still working. That entity is a type 32. It has an 8-round collidable here. So we're never getting to here. Our base behaviors should be set. Okay, we have our collider circle. Should have behaviors. Collision door. Ever being built. Let's look at the spawner behavior here. Duplicate. Spawning, and it's time passed. We check the frequency. We need to build it. Needs to be built. Which is in room that this. Duplicate. Don't want to mess with that value, so entity is equal to no, this is the duplication. We want where we actually create them. Say new entity dot build. don't actually want to allocate space for that. If added like I could just set it to default to empty or pass in an empty list, but that means I'm allocating an empty list. Then in room, we just need to do this. We build it, we add it. That again. Run that again. Oop. No. It is colliding. Its passage entered. Okay. One and the player. Then door entity should be listening for, passage should be listening for on passage entered, but this didn't trigger. Because the passage isn't listening for that yet. Which means in the level, we are calling load on the passages. Passages are not being loaded up at all. The level does not contain them. Passage being duplicated properly. It is not. Each passage in passage in passages duplicate passages.add passage.duplicate as a passage. And then when we are doing this, it can be for each passage. Oop. Okay, everything broke down when that happened. Here. So, mice in the air. Teleport, mice stop. Because that was deactivated when that happened. So we're triggering a room entered here. So exited, entered, passage exited. They're supposed to deactivate, but we should be re-entering that room. So the corresponding room should react to a room entered. Exited on room entered. Room entered, we are room 1, and we are inactive. So we're going to touch here. So it is, we're leaving room 1, and we are active. So we deactivate the room, and deactivating the room stops looking for exited, but it's still going to look for room entered. And it is going to stop looking for entities. We got a room exited twice. Why? We entered the room, we activate it. So now we are active, and we have activate. We are now watching for room exited. We are watching for entity added, and we have created entities. So then I touch this. Room exited. So we are going to hop along here. We exit the room. We deactivate the room. So room is no longer active. We are going to stop listening for room exited. Right here. Come here. Come here. I'm here. You're being a nuisance, Sky. You're being a nuisance. It's crying at me. And then we're back around again. Like we attached room exited twice. Let's attach, detach. Deactivate the room. Detach room exited. Detach entity added. Like it got attached twice is the problem. Come here. Oh, okay. We're going to have to look at this one a little bit further, but I think we're at a good stopping point for the night. Buttons. Gonna check on the kitties anyway. He's probably out of food and is upset about that. Yeah. Oh, progress tonight. We are at the stage where it is very close to working, barring some debugging. We just have to get that room activation deactivation sequence to be fully functional. We'll have to see on that, though. Assuming I can get that together cleanly, then our next step is going to be positioning the rooms in space with corresponding images. And then we begin the song and dance of converting those images into, like, effectively physical space, which will be its own thing entirely. But we'll see how that goes. But for now, folks, I hope you had a good time watching with us tonight. If you like what you saw and would like to see more, remember to like, follow, subscribe, comment. A majority of those buttons down there are good, and I would appreciate it if you press them. If you'd like to consider financially supporting the channel, you can do so through platform-specific means like bits, membership subscriptions, as well as through other means that are available through the link tree in my bio and video descriptions. With all that said, though, I hope the rest of your day is good, and I will see you next time.